Hello, this is Mrs. Ringrose, and we are back at it again, trying to learn all about stuff for pre-calculus. So I thought this would be a good place to have a video because you've seen 1 over x and you've seen 1 over x squared, and those are going to be our parent functions for the rational equations that we're going to be working with. So some of the basic goals I want you to get out of today's video lesson is to be able to sketch graphs of rational functions, and we're going to accomplish that by identifying some characteristics like asymptotes and end behavior, and then we can get right to the hard stuff when you come into class next time. So some good vocabulary to know is that we consider a rational function when it looks like one polynomial function divided by another polynomial function, and the bottom function, the denominator, can't be equal to 0, right? Okay, so the graph of our parent function, 1 over x, is called a hyperbola, and it has two symmetrical parts, and we call those parts branches. You guys know what that looks like. Sketch a little graph right here. We got this branch, and we got that branch, right? And the domain and range are all non-zero real numbers, because on our parent function, it does not go through the x-axis, and it does not go through the y-axis. Next, I think finally, maybe, we have a word that you may or may not have heard before. I might have used it. It's the asymptote, and that is the part of the function that the graph does not go through, actually. So in our parent function, you can see that the branches get really close to y equals 0 on both lines, because it gets really close to the x-axis. That would be considered the horizontal axis. I'm sorry, the horizontal asymptote. And then the vertical asymptote on this one is the line x equals 0, because it gets really close to the y-axis, but it never touches it. So those are the words that you want to study. And we're going to use some of that knowledge to sketch some graphs. So we're going to find the vertical and horizontal asymptotes for each function, state the domain and range, and then sketch the graph. So number 1, we know that x cannot equal 0, and that means my domain is in interval notation, looks like this. Okay. Turns out that there's no vertical shift, so the range is also going to be that it does not go through 0, and it's going to be the same. Okay, and this looks very similar to our parent function. And if you want to use a graphing calculator just to get another idea, the one thing that is different is that the numerator has a negative, so it is going to be flipped and in different quadrants than what you're used to. Okay, so that's a good sketch of that one. For this one, again, my domain does not equal 0. Because I cannot have 0 in the denominator of that fraction. But then my parent function has been shifted down 5 units. So what's going to happen is y is not going to be able to go through -5. And the sketch of that graph will look like, we're not going to really even account for the 8 because it's just a sketch. But here's -5, so x can't be 0, so it's going to look like that, and like that. So it's never going to hit the y-axis, but it definitely can go through the x-axis, because we can set this function equal to 0 and then solve. Okay. Then number 3. So on this one, you know that to solve for the domain, x minus 3 cannot be 0, which means x cannot be equal to 3. It also has a vertical translation up. So what's going to happen on this one is y will never be 2. So if we sketch this graph, it's going to move over 3 spaces and up 2 spaces, and it's going to look like this, right? So there's no flip or anything like that. And we call all those spaces where the graph does not go through, we call those the asymptotes. So that was one of the things that I was supposed to do, actually, was to talk about the asymptotes. So going back to number 1, because x cannot equal 0, this is my vertical asymptote is at this line, x equals 0. My horizontal asymptote is at the line y equals 0, because those are the lines that the graph approaches but never touches. This one, the number 2, the horizontal asymptote is y equals -5, right? Because this graph is never going to go through it. And then the vertical asymptote is the line x equals 0. So it's basically, where the number or the value that's not part of the domain or the range is going to be your asymptotes. And then on number 3, the vertical is x equals 3, and the horizontal is at y equals 2. And you should definitely plug all those into your graphing calculator and just double check that we have all the shapes correct. Alright, so now we're going to get into something a little more heavy. So if I give you any rational function where there's a linear on top and a linear on the bottom, again, these are all graphs that are hyperbolas, and we can very easily find the asymptotes by doing this. You ready? So we know the denominator cannot equal 0, right? That's part of my domain. So that means that my vertical asymptote can be found by setting this equal to 0 and then solving. So my vertical asymptote is found by taking those numbers in the denominator and solving for my what my domain restriction would have been. The horizontal asymptote is a little bit different. So what's going to happen is to find the horizontal asymptote. Alright, so to find this one, actually what we're going to do is we think about the numbers that we can't put in for x, and we're going to be left with a over c. So my b, we don't even care about b, I guess. My horizontal asymptote is going to be a divided by c, and my vertical asymptote is going to be solving for that domain restriction in the denominator. So I hope that makes sense. So then we have something to practice, okay? So I can sketch this graph really easily using what I just learned about where my asymptotes are. So first let's do the vertical. The vertical is when we actually solve for x. So this is going to be where the denominator is equal to 0. So my vertical asymptote is going to be x equals 4. And then my horizontal asymptote, where it's not going to go through, it's not going to ever reach this output, is we take 2x and we divide it by x, and so we're just left at 2. So we just worry about the front part for the horizontal. So now I'm ready to sketch. Okay. So here's my axes. I have a horizontal asymptote at y equals 2. I have a vertical asymptote at x equals 4. And I'm not going to really worry about the other numbers because this is just a sketch. But it's going to look like that. I should have made this different color. Bloop. Bloop. Also for sketching, if you can put in some points like maybe x equals 0 just to get like another good anchor, you can. So I can put 0 into this function. It's not a domain restriction. F of 0 actually equals 2 times 0 plus 1 over 0 minus 4. So it looks like it's negative 1/4. And wow, my sketch is so good. That totally could be negative 1/4. So I don't know, before you start sketching, if you just want to do that, that might help your drawing. All right, so I'm going to wrap this up and we can do some harder stuff in class. But before I let you go, we can also take this information and go backwards. So in your notebooks, what I'd like to check while you're working on the warm-up is if you can answer this question. So write a rational function such that the domain is all real numbers except -8, and the range is all real numbers except 3. Think about what that looks like, where those, where the asymptotes are, and then you can work backwards from there. And that's it. So I'm going to write this. I want to see this answer to see if you understood the stuff that I was saying today. And I hope you enjoyed this video. Have a great day.